A railroad track and a road cross are at right angles. So railroad and a road cross are at right angles. An observer stands on the road 70 meters south. Here's my observer. And watches an eastbound train traveling at 60 meters per second. So that means he's headed east. I don't know where he is, but he's going this way at 60 meters per second. At how many meters per second is the train moving away from the observer? So how many meters per second is this distance for the train versus the observer? If the train moving away from the observer 4 seconds after it passes the intersection. Okay, so I guess if this is the intersection and he's going this way, 4 seconds later he's going to be somewhere over here, and he's going 60 meters per second. And so we're actually trying to figure out the distance between the train and this observer, how fast that is changing. Okay, so our first task there is really to understand the question and get it set up.
I think it's supposed to go the other way.
Oh, eastbound. Yeah, it's heading towards east. Thank you. Okay, so is that the picture that y'all had, or is that where you got stuck? Okay. Are you okay with how I did all that? Okay, so again, be careful. Like, I feel like it's just a touch harder for me because I'm trying to work it and explain it and write it, but still, you got to be careful. Eastbound, it's heading towards the east. So a little mistake like that could have tricked me at the end. Okay, but now that I've got that behind me, it looks like it's probably going to be a Pythagorean theorem question. That's the most common. We know we got to take the derivative at some point. Okay, all of these have a 2, so divide everything by 2 now or later. Yeah. And from the other questions we've done, we're going to plug in the stuff that we have, hope that we have everything except for what we need so that we can just solve and be done. So if this is a right triangle, label the legs A and B. The hypotenuse has to be C. So what is A going to be in this question then? Okay, and A prime? Okay, again, I guess you could have called this A, but I'm just saying let's use this as A. So I've got both of those. That's a good start. B, well, oh, I do know this length, don't I? 70 meters. Kind of lost it in my work there, but it is there. Times the rate of change of B. Well, how is this length changing? Not, so that's a 0. These often have a 0 rate of change somewhere in there. C, I don't know this length, and C prime is the whole point of the question. How is this length changing with time?
Define with A, you have done like 60 times 4, and that's the distance.
Oh yeah, it should be distance, right? If this is 70, because A is supposed to be a length, not a time. If B is a length, then A needs to be a length. So yeah, you're correct. So right here, Now, because I keep up with my units, I would have caught that at the end. I would have realized my units don't make sense. But 4 seconds going 60 meters per second means that this length is actually 240. Okay. But if I'm trying to solve for this, I'm not quite ready there because I don't know C. So we've seen now with just from practice that we probably can get C over here to the side by thinking of Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. And the square root of that's probably not going to come out to something perfect. Actually, it is. So it looks like C is 250. That would be in meters. So the hard part should now be behind us. We've got an equation and we just need to solve for our variable. So 240 meters times 60 meters per second would be 14,400 square meters per second. This goes to 0. 250 meters times C prime. Divide both sides by that. I got 57.6, and meter squared divided by meters would be meter per second. Had nothing to combine with, and I guess that didn't matter on this multiple choice because they didn't even put the units anyway. But if I had not caught this 4 seconds, changing it to a length, I would have realized my units don't make sense. I was trying to find a speed here. I knew it needed to be meters per second. So if I didn't end up with meters per second, then I forgot to change something over. So 57.6, that should be choice A. And that's great. So still a Pythagorean theorem question. We practiced this maybe 10 times now. So this part's pretty familiar. Finding this part should be pretty familiar to you. But interpreting the question, getting the picture set up, making sure you have the picture correct takes some time. So, okay, is that enough for 7?
I have a question about it.
Okay.
I'm just confused about like the 4 seconds part.
Uh-huh.
Cause like from the way I understood it, it was I like saw it as like 4 seconds after the intersection, not like before the intersection.
Oh, it is after. Okay, but okay, yes, you're right. So the 4 seconds is actually over here after. So it's over here. So this is 4 seconds, but 4 seconds at 60 meters per second. So this length here is 240 meters. So I'm really trying to find this, but then everything else is consistent. So you're right. My picture was not accurate, and I was just lucky that it didn't mess anything up. So I guess what I'm learning out of this question is I need to be more careful with setting up my picture.